Hello there, it's exercise 6E.2. We're going to look at how circles intersect. How they intersect both straight lines, and you can see I've got three examples there of a straight line trying to intersect at least a circle. And you'll notice one of them, this one here, it intersects in two places. So the y equals x plus 1. I don't know what the circle is, but you can see it hits in two places. And very importantly, 2 points. Whereas this line, it says that line is x is 1, it just touches. And when it just touches, it literally, obviously that's one place it hits. And we call that line a tangent, so it's important to know that word. And then we have this third example, it kind of doesn't hit at all, no intersections. And it just misses, it just tries it best and misses. So that's one thing we're going to do, and we're also going to look at how two circles intersect as well. So there's lots to get through. So anyway, number one, intersections of lines and circles. And I've just explained that when you have a circle, you can have a line that hits it in two places, or one place, or not at all. And this is a common feature of what we're trying to do today. How can we try to find these points of intersection? You may recall that at GCSE very often you might, for instance, have GCSE, a not much easier question. You might have a quadratic graph that does that. You might have a straight line graph that does that, and you try to find these 2 points. And the way you do it really is the method of substitution. So you've got your line here, which is y equals, I'm going to make one up, x squared minus, no, probably have plus 3x minus 5. And you've got your straight line, which might be y equals 2x plus 1 or something like that. I made that up. But you basically got y equals this and y equals that, so you can set them equal to each other, you can solve it. But this is a bit more complicated because I've got a circle. But it's not impossible. One thing we can use is the discriminant. The discriminant is kind of linked to what we're going to do. When we do our equations, the discriminant then will inform us how many places it will cross. So just be aware of that. It was trying to do this thing again. When we get our quadratic equation, you should remember that the discriminant, b squared minus 4ac, to get two results, it's got to be greater than 0. But when I do it, if I only get one result, that's because it's just a tangent. And I'll get one result when b squared minus 4ac equals 0. And notice I've said 1 point of intersection. But when you get no points, well, that's when our b squared minus 4ac is less than 0. That should be just like a carbon copy of what we've seen with just normal quadratics. I suppose we've got to get the quadratic first of all. So let's show you what I mean by that. It says use the discriminant to show that the line y equals 2x. We've got this line. And the circle, now look at this. This is not such a pretty circle. It's a quadratic equation, the example I showed you at the start of the PowerPoint, are easier equations. You'll notice it says x squared plus y squared. But essentially we do the same thing, because I know that y equals 2x. So by substitution, wherever it says y, I write 2x. Wherever it says y, you notice it says it in two places. So just at the top here, I'm going to write x squared plus, no, not y squared, no, because y equals 2x. I'm going to write in brackets 2x all squared. Minus 2x, well that's fine, but it's x's. Minus 4y, oh, can't write that. I've got to write the y as 2x, so 4 in brackets 2x. And that equals 0. So this becomes an equation, x squared. Now be careful, 2x squared is not really 2x squared, because the 2's got to be squared as well, so that becomes 4x squared. This is minus 2x and minus 8x. Okay, that's fair enough. So what have I got here? I've got x squared, well I've got 5x squared, you can see that, minus 10x. Well, that actually is not too bad. There's not a number at the end, it's relatively easy to factorise. Factorise it by taking 5x out as a common factor. And in brackets, 5x times x gives me 5x squared, 5x times 2, or minus 2, gives me the minus 10x. So this gives me two places. It says, well, I should point out that I am, if you like, not doing it properly. I'm solving it. I'm actually doing part 2. X equals 0 and x equals 2. 0 because 5x is 0, so therefore x is 0. 2 because 2 minus 2 will give me 0 as well. So I have down here Find the coordinates of these 2 points of intersection. Well, I reckon x is 0, is 1. Notice, by the way, y is 2x, so therefore y is 2 times 0. And if you like, that is definitely 0, 0, because 2 noughts are 0. The other point I said was x equals 2. Again, y equals 2x, so y equals 2 times 2. Well, 2 times 2 is 4. So my second point is 2, 4. 2, 4. They are my 2 points. How can I have used the discriminant then? Well, once you get your quadratic equation, there was our quadratic equation. So notice on this, you write the a, the b, and the c. Oh, I don't think there is a c actually either. A is 5, x squared. B is minus 10. And c is 0. So when I put these into my discriminant formula, b squared minus 4ac equals, let's do it, b squared, well that's 100, minus 10 times 10 is 100. Don't notice the minus doesn't bother me at all. Minus 4 times a, which is 5, times 0, oh, 0. Times anything by 0 is 0, so my answer is 100. This is greater than 0, so therefore there will be 2 points of intersection. I was too lazy to write points of intersection. And I found them. I found it. One was 0, 0, and one was 2, 4. Okay. Use the discriminant to show how the circle, what was the circle? The circle was this horrible thing again, intersects the line y equals 2x plus 5. Alright, so this is the same question, just made more complicated. Let's try it. So my circle, remember, was x squared plus y squared. Oh, I can't write y. I have to write what y is. What's y this time? Y is this 2x plus 5. So let's write it. It's x squared plus 2x plus 5 squared. And then it says minus 2x, so I can write that. Then it says minus 4y. Can't write y. I have to write 2x plus 5. It looks more complicated, certainly. So let's multiply it out. X squared plus, well, probably best to write this as 2 double brackets. Because people, when they don't write it, they always make mistakes. So I've come to the conclusion you should really put double brackets whilst you're starting up. 4 lots of 2x is 8x. And minus 4 times plus 5 is minus 20. The one I didn't let you do is this one here. This one gives me, when I do it, 4x squared. What's that? Plus 10x. Plus another 10x. So I'm going to write plus 20x. Plus 25. I don't really need the bracket now. Got an x squared at the front. That minus that, that's minus 10x and minus 20. So that's equals 0. Come up here. Let's try and do this. So I've got x squared and 4x squared. I reckon that's 5x squared. I've got 20x minus 10x. I reckon that's plus 10x. And I've got 25 minus 20. What's that? Plus 5. Equals 0. And it says use the discriminant again. So I'll do it properly. Really, at this stage, I shouldn't try to solve it because it tells me not to. So I shall try to solve it. A equals 5. B equals 10. C equals 5. I think I said I was going to solve it again. I'm not. I'm going to use the discriminant. B squared minus 4ac. So b squared, 100 again. Minus 4 times 5 times c, which is 5. Well, 5 5s are 25 times by 4 is, that's 0. That's 100. 100 minus 100 is 0. So this is 1 point of intersection. 1 point of intersection. I can't be bothered right there. If it does find the points of intersection, well, there's only one. How do I find it? Well, I have to solve this equation. So having done that and not solved it, I now know there's one solution. I'm going to find it. So first thing I can do is divide it all by 5. Notice this, divide 5x squared, I get 5. Divide by 5, x squared plus 2x for the 10x plus 1 equals 0. And actually that's a really nice thing to factorize. It's x plus 1 equals 0, and therefore x equals minus 1 is my solution. Now that's only an x coordinate. Notice I can chuck it back into my y formula to get my y coordinate. Well, that'd be 2 times minus 1, add 5. What's that, minus 3? No, plus 3. So I think my coordinate is minus 1, 3. Let's see what my answers say. 0, 0 and 2, 4, minus 1, comma 3. I think I've done that right. Use the discriminant to show that this line, I lost my pen, there it is, this line intersects this circle. And it says show how it intersects. So that means use the discriminant anyway. So this time it's in bracketed form, but you do it the same way. X plus 2 all squared, I can write that because that's in x's. Plus y minus 1, can't write that. But luckily I know what y is. It's x minus 1. So I'm going to write in the bracket x minus 1 minus another one. Because that's what I have to do. Squared equals 4. So I've got to multiply these out. This is x plus 2 all squared. So put double brackets. And this is really x minus 2. If you do minus 1 minus another, it's x minus 2. But it says squared, so I've got to do that. Equals 4. So let's multiply it out. I get x squared. Now if you multiply this out, you get 4x plus 4. See if you can do that. If you can't, if you don't believe me, x squared minus 4x plus 4 equals 4. There's a lot of 4's going around here. X squared and x squared is 2x squared. 4x minus 4, they disappear. 4 plus 4 is 8. So I've got plus no x really, I suppose, that's what I'm saying. But the 4 plus 4 is 8, and that 4 moves over and gets me, I think, 4. So I've got 2x squared plus 4 equals 0. So if you like, my a is 2, my b is 0, because I've got no x's, and my c is 4. So I put it into my b squared minus 4ac formula. This is my discriminant. What do I get? I get b squared is 4 minus 4. Oh, my b squared is 0. I'm talking rubbish here. My b squared is 0 minus 4 times a times 4. Okay, that's 0 minus 4 4s are 16 times 2 is 32. Well, I think I get a negative answer. That's minus 32. That is less than 0. Therefore, there are no points of intersection. That's exactly what I've got. It's less than 0, which I've got, and no points of intersection. Now, I'm going to save this for the next lesson because there's lots to do on this. So far, we have just looked at intersections of a line and a circle, and we've highlighted the fact that with a line and a circle you can get 2 points, you can get 1, or you can get none. You can tell how many you're going to get by using the discriminant, and very often the exam question will say use the discriminant to explain how you know how many there are, or force you to use the discriminant for some other reason. And sometimes they say to you, and by the way, now find the point of intersection, and we've done that as well. We've done that in 2 examples, but I haven't yet talked to you about the intersections of 2 circles, which we will do in class. So, thank you very much.